In this video, we are going to solve a probability problem involving dependent events. It's a problem about conditional probability. The question gives that a cabinet contains 6 cups and 8 plates. Sandy repeats drawing one item at a time randomly from the cabinet without replacement until a cup is drawn. We need to find the probability that Sandy needs exactly 3 draws to get a cup and at most 3 draws to get a cup. Let's draw a diagram to show what Sandy will get for each draw. There are 6 cups and 8 plates, a total of 14 items. So in the first draw, there's a probability of 6 over 14 to get a cup and 8 over 14 to get a plate. If she draws a cup in the first draw, she'll stop, otherwise she'll keep drawing. Since no replacement will be made, in the second draw, there will be 1 item less than in the first draw, that is 13. There are still 6 cups, so the probability of getting a cup now is 6 over 13. 1 plate has been drawn in the first round, so the probability of getting a plate now is 7 over 13. The patterns continue for subsequent rounds of drawing. The probabilities of drawing a plate and a cup will change after each round. That means the first draw, second draw, and subsequent draws are dependent events. Now let's see how to find the required probabilities. Part A, we need to find the probability that Sandy needs exactly 3 draws to get a cup. Not more, not less. That means she has to draw a plate in the first round, and another plate in the second round, and then a cup in the third round. We've mentioned that the draws are dependent events. To find the required probability, we need to find the product of these 3 probabilities. In more detail, we are finding the product of the probability of getting a plate in the first draw, the probability of getting a plate in the second draw, given that a plate is got in the first draw, and the probability of getting a cup in the third draw, given that 2 plates are got in the first and second draws. That is 8 over 14 times 7 over 13 times 6 over 12. And the result is 2 over 13. In part B, we need to find the probability that Sandy needs at most 3 draws to get a cup. That means we are looking for the probabilities of her needing 1 draw to get a cup, 2 draws to get a cup, or 3 draws to get a cup, but not more than that. We'll add up these probabilities to get the answer. Getting a cup in exactly 1 draw is simply the probability that Sandy draws a cup in the first draw. That is 6 over 14. The way to find the probability that Sandy needs exactly 2 draws to get a cup is similar to part A. We multiply the probability that Sandy gets a plate in the first draw by the probability of getting a cup in the second draw. That is 8 over 14 times 6 over 13. The probability that Sandy needs exactly 3 draws has been found in part A, which is 2 over 13. We add up the probabilities. Therefore, the required probability is 11 over 13. That's it.